In this illustration, we'll analyze the interference of direct and reflected light. We are given that a point source S emitting light of 6000 angstrom wavelength is placed at a small distance from a mirror AB as shown. An interference pattern is obtained on a screen placed at a large distance parallel to the mirror. A mirror reflects 36% of the intensity incident on it. We are required to find the ratio of maximum and minimum intensities on a screen and shape of fringes obtained. And if it is saying initially at a screen center there is a maxima, we are required to find by what distance mirror AB should be shifted so that again there will be a maxima at point O. So here in this situation we can simply write if direct light intensity at a screen is I, then intensity of reflected light on a screen will be, this can be written as 0.36 I, because we are given the light which directly going from S to O and the one which is reflected and going from S to O or S to screen. This reflected light has 36% of the intensity which is incident on the mirror. So it will be 36% of the intensity of direct light. So here as we are having the intensities of the two lights which are reaching a screen, we can directly write the ratio of maximum to minimum intensities on a screen is, this is the contrast ratio which is given as I max by I min, and we already studied that its value is given as root I1 plus root I2 upon root I1 minus root I2 whole square. So in this situation this root I minus this root 0.36 is 0.6 I. So this will be 1.6 divided by 0.4 whole square, and the numerical value is 16. That is the result of this problem for the contrast ratio on a screen. Now we also need to calculate the distance by which mirror AB should be shifted so that at point O the maxima should be retained. Now in this situation we can see if this is the location of mirror and this is the source. So for a screen, here we can say if at point O there is a maxima. So for this to be a maxima, here path difference must be equals to n lambda. So one light which is directly going to O and other is reflected and appear to be coming from the image of the source. So you can see this is reflected and going back. So the two waves will be having a path difference which can be given as one is direct, other is traveling a distance 2x, as well as reflected from the mirror. So the path difference can be written as 2x plus lambda by 2, where 2x is the axis path, physical path traveled by the reflected light, as well as lambda by 2 is the axis path due to reflection from the denser mirror. So here we can say the path difference at O in the two light beams is, this we already calculated as 2x plus lambda by 2. Now here we can write if mirror is shifted left by a distance y, then path difference will be Now the path difference will be delta prime, and this can be written as twice of this distance will become x plus y plus lambda by 2 is still there. And initially if path difference is n lambda for a maxima, we can write after shifting this path difference should become n plus 1 lambda, as this is the next maxima which is obtained at O. So if we further simplify it, here we can solve it. This will be 2x plus 2y plus lambda by 2 is n lambda plus lambda, which gives us y is equals to lambda by 2. As lambda is 6000 angstrom, this is 3000 angstrom, by which the mirror should be shifted so as to obtain another maxima at O. That is the result of this problem.